Hi guys, welcome to Science Play. I'm here back with another video. My video is to how to make a Tesla coil. And the potential at the spark gap is applied to the primary coil, and this flux again induces the high voltage, high EMF in the top load. The first step in making our Tesla coil is the secondary. You can take a plastic tube and a winding wire. You can oil it or recycle it from a motor. You should try and make turns without keep it like it and keep on going. Make turns until you make 1000 turns, which I have already made. Which I have already made 1000 turns. After this, you need to go for making a capacitor. Make sure that the capacitor should be able to bear the voltage that you give. There are two circuits which you can make for two different power supplies. This is the circuit that corresponds to high voltage DC power supply. This is the circuit that corresponds to high voltage AC power supply. First thing you need is you should make sure that the current to the primary coil should always enter from the spark gap. That the spark gap through the capacitor. And this is for high voltage. In this, the capacitor charges with the DC power supply, and the capacitor discharges through the spark gap, and the air resistance here breaks down and discharges through the primary coil. The flux produced in this coil induces a very high EMF into this coil, into the secondary. That is where you can get the tower with a high potential, which is greater than 10,000 volts. And coming to, if you have a AC power supply which high voltage, the first cycle comes in the charging of capacitor. The first cycle in this way, the second cycle in this way, until the capacitor charges. Once the capacitor charges up to the voltage that the spark gap breaks down and conducts the electricity. The capacitor I made, and you can use a aluminium foil and a transparency sheet that are available in the outside printer shops. Take a A4 size transparency sheet, cut into equal pieces, and place a aluminium foil of length 18 to 3 centimeters. And now I am going to show what is inside this capacitor. Then I make sure that you can understand about it. I am going to remove the tapes. The tough, you need to roll it very tight, and you should be careful while rolling this. It must be. Actually, the capacitor, I have already used this for many of my experiments. This is inside the capacitor. I have used simply two aluminium foils. Actually, this capacitor, this plastic, this polythene melts while you give a high voltage power supply. That is why this is not coming that much freely. Right. There are two aluminium foils, which are in between. I have placed two sheets of transparency, and which acts as a dielectric. Actually, these two sheets in between two aluminium foils can act as a dielectric, because these are made up of polythene, which is a perfect insulator, and aluminum foil is as a good conductor of electricity, and these two acts as two charging plates. When you supply this, the energy will be stored in the form of electric field, as we all know that. And we always make the capacitor is because we always use the capacitor because the capacitor has the ability of not allowing the sudden changes in voltage into the circuit. Now when you apply the high voltage, the high voltage is suddenly will not go into the spark gap. If it enters gently, the spark gap may not produce. By using the capacitor, the complete charge of the capacitor is applied to the spark gap and the spark is generated. And I have showed you how to make my capacitor very simply, and I have already made the capacitor. And for coming to the top load, for this also you can use a aluminum foil and a plastic ball. You can roll it just as I showed in my video. And you need to cut this piece using a scissor or whatever. Spark gaps using the terminal blocks that are available in the market and a copper rod. You can simply take 2 blocks up to here, you can cut it, and use a wire cutter to cut these blocks and make a spark gap, and you can make your spark gap. Our completely connected Tesla circuit. This is the high voltage power supply which I have showed in my last video how to make it, and I have kept my flyback or all of the stuff in this and make it as a look really good. And neatly I have neatly insulated this twice, and I have made used insulated tape to make difference between the positive and negative terminals. And as I said, this is the top load, and you should attach to the top load to the primary coil this way, and make sure that this top load is making good connection with the primary coil. For this you need to remove the insulation on the winding wire. You can make it on fire, or you can use a blade to remove this insulation. And I have attached the top load. You can make the primary coil using a common general wire, and you need to make 10 turns or as more than 10 is more than enough, 10 turns. And you can take any insulated type box or which I have taken, or you can use another plastic pipe which can be kept here, and make 10 rounds and connect it as I did it primary, and that's it. Okay, this is the power supply. This is the positive terminal of my circuit, and this is the negative terminal. This is the capacitor. As I have a high voltage DC power supply, this is the supply, and from the supply the 2 wires goes to the capacitor, and from capacitor to the spark gap. I already told you that you can use a terminal block. Zoom in. You can use 2 copper wires for the spark gap. Right? You can use 2 spark gap by a terminal block, and from the spark gap you need to connect to the primary coil, and another terminal of the primary coil to the another terminal of the capacitor, and this goes to the negative terminal of the power supply. And if you want to make a power supply, you can watch my previous video. I have showed you how to make a simple DC power supply using a flyback transformer and a lamp and a fluorescent lamp. You can watch. Okay, now let's see the output of this circuit. See, I am just plugging our power supply. We should be careful that you need to make all insulations. I have not made these insulations, but you need to make it. And I will now switch on the power supply. Spark gap produces spark gap. This is the high voltage capacitor. When you bring any fluorescent lamp into this coil, it always needs to glow. And this, the bulb glows when you bring it near the power. And the bulb also glows. Actually, I will not get a shock when I touch it. Screwdriver and the top load. Actually, the voltage at this is more than 10,000 volts. If I touch this, I will not get any shock, but I will feel a small burning sensation of my skin. Usually, why I cannot get any shock, because it is not actually the voltage. The current makes a spark between this. The voltage on this board is more than 10,000 volts. But actually it is a good conductor. If I touch this, I will not get any shock. Why I am not getting any shock even if I am touching the tower which is more than 10,000 volts? Because the voltage will not make us feel any shock. The only shock we are feel is due to current. Actually, this is a high potential tower, but it has a very low current. The current which may not make human body to feel a shock. As the voltage is only the energy of the charge, not the flow of the charge. When the current is the flow of the charge. That is why the potential of this tower is more than very high voltage. Even the resistance in the air is breaking down between this screwdriver and the top load. When I keep it near, if fast loads.